All right, welcome back. So I am all about AI. I've been turned into an AI realist after reading Situational Awareness by Leopold Aschenbrenner. And I want to point out one really influential figure, Peter Voss. So Peter Voss, not the Peter Voss, the not this Peter Voss, the other Peter Voss, the brilliant scientist. This guy. So he has a whole career in science. He started as a electrical engineer, a global citizen, born in Germany, worked in South Africa, lives in the United States now, and one of the one of the people who came up with this term AGI. So a whole career in AI, a really influential person in AI. And I just wanted to make sure that people on my channel were aware of who this person is, because if you go into his online presence, which I definitely recommend everyone does. So if you just Google Peter Voss YouTube and watch some of his podcasts, he also has a website, blog, optimal.org, where you can read about some of his personal philosophies, which I definitely recommend. Health and longevity stuff, I think it is valuable to read about. Ethics, philosophy, and then he's got his own interviews and talks that he finds notable enough to put on his site here. Although maybe this isn't the best place to go, because we got a 404 error. So just do a basic Google search and check out some of his podcasts, because he has a different approach to AI and AGI. So LLMs are limited in what they can do. It's still very much a narrow form of intelligence. It's a generative GPT. GPT stands for GPT technology. And I spelled that wrong. It's GPT, not GTP. So generative pre-trained transformers. So right there, that's all you need to know. It's generative, which means that it makes stuff up, right? It doesn't learn on the fly. It doesn't take things as it comes. It pre-generates the answer and gives you the pre-generated answer. Wrong. That's not how humans work. That's not what intelligence is. Intelligence works on the fly. It's pre-trained. Again, wrong. Intelligence should come up with novel solutions without requiring any pre-training. So that's something you'll hear him talk about, is the flaws of the current approach to AI, and some of the more exciting ways that he's been trying to race to get to AGI. So elgo.ai is his business website. They've done work for like 1-800-flowers.org to set up their call center. So this is very much a rugged here and now entrepreneur developing and selling products for modern businesses. This isn't some academic person stuffed away in on campus, right? This is a scientist out in the real world applying their science. So and no offense to academics. I'm sure university research gets out there in the real world as well. But Peter Voss is a college dropout, lifelong serial entrepreneur. Or sorry, high school dropout actually. So that's pretty much all I wanted to say about that. Is that there's more than one path to AGI. This GPT approach, that's ChatGPT and these other companies, Anthropic, that work on Claude, are taking requires massive amounts of pre-training, right? And compute and exposure to priors, right? But that's not how intelligence works, right? You should be able to come up with novel solutions in real time without any sort of pre-exposure to the problem. You should be able to solve a puzzle. You should be able to solve a maze without having solved a similar puzzle of its type before. That's really what intelligence can do that is special, right? So you know, some of the things he talks about is metacognition, which for me, and I don't like to talk about this, but you know, I've had some struggles with mental health in the past, and metacognition has really helped me. It's thinking about thinking. So like, instead of thinking, oh, you're not good enough, you're not worthy, this, you know, you can think, what is leading me to these thoughts? Well, I'm in a situation that's intimidating. I might have imposter syndrome. So you can remind yourself, well, you know, maybe I don't have the same credentials as everyone else, but I gave it all I got to get here. I do have these credentials which qualified me. I was hired, so it doesn't matter what I think. It matters that the company believes in me and the hiring manager believes in me. So that's metacognition. You think about your own thinking, and you can kind of make adjustments in the way you think as such. LLMs can't do that. They by nature, by their technology, can't do that. So there's better ways, and to learn about them, I urge everyone to go follow Peter Voss and check out some of his podcasts and his writing online. If you prefer writing, he actually has writing, but it looks like his main presence is through like podcasts and stuff. All right, so no time to waste. Let's stay on topic here. I just thought that was a worthy aside, especially in a series I'm doing now that's related to AI. So the series I'm doing now is the Nvidia certification. I just want to send out a strong signal that I'm an AI guy. I know about AI, so there's no better way to demonstrate that than to show I have a certification specifically in some field of AI. And I feel like there's no better certification to do that than one that is entry level, and that I can pick up a solid half hour, and that I can pick up quickly. So I think this checks all the boxes. This is the Nvidia AI in the data center. So why in the data center, especially since this isn't listed officially on their page, and especially when there's other options such as generative AI and LLMs, you know, the big hot thing, multimodal generative AI, InfiniBand, which could be really hot going forward, depending on how things work out. You know, well, it's because this multi-trillion-dollar industry is going to go into data centers, in my opinion. So it's something that explicitly calls that out and says, I'm interested in data centers. I know about data centers. I think is a good choice. And then it fits the bill. It's the lowest priced exam. It only takes an hour. And all the training is here. I can do it on my YouTube channel without worrying about, like violating a copyright. So that's my reasoning for that. Hopefully it's good reasoning. Brought to you by metacognition, thinking about my thinking. I mean, that's not necessarily thinking about my thinking. Thinking about my thinking would be more like, why am I doing this? Like what am I thinking when I make these videos? And what I'm thinking is that I have a deficit in my focus that I have to overcome through this sort of format. And honestly, I've been thinking about that a lot lately, because this sort of format, even though I get things done and I have it to prove it, you know, I've had failure after failure with the LPIC, with the NCA-AIIO. You know, there has to be a better way, right? But hopefully I'll have a success here. That will really help my confidence going forward. All right, so we got 9 minutes, and I'll be able to finish all of this now. I've got plenty of time this morning here. So let's get 9 minutes on the clock, knock this part out, and then I might need to take a break. And I'm actually going to take a little break before I start this. This introduction here was about 10 minutes. So I need a little bit of a glass of water before I start reading so much. So I'll be right back. All right, it should be good to go here for at least for 9 minutes. Probably take me longer than that. All right, so this is achieving a cloud scale architecture with DPUs. And remember, we read about DPUs. They develop their own chips specifically for data center functions. And Mellanox, the reason it was originally published on Mellanox is because Nvidia acquired Mellanox switches. Mellanox is a networking vendor out of Israel, from what I understand, or France. I actually don't remember, but I've worked on them before in a prior contract. They're a little bit like Cisco's, but they have support for InfiniBand and Ethernet, and they have really a high throughput capacity. In the first post of this series, I argued that it is a function and not a form that distinguishes the SmartNIC from a data processing unit, DPU. I introduced the category of data center NICs called SmartNICs, which include both hardware support or hardware transport and a programmable data path for virtual switch acceleration. These capabilities are necessary but not sufficient for a NIC to be a DPU. A true DPU must also include an easily extensible C programmable Linux environment that enables data center architects to virtualize all resources in the cloud and make them appear as local. To understand why DPUs need this, I go back to what created the need for DPUs in the first place. Why the world needs DPUs. One of the most important reasons why the world needs DPUs is that modern workloads and data center designs impose too much networking overhead on the CPU cores. With faster networking, now up to 200 gigabits per second, the CPU just spends too much of its valuable cores classifying, tracking, and steering network traffic. These expensive CPU cores are designed for general purpose application processing, and the last thing needed is to consume all this processing power simply looking at and managing the movement of data. After all, application processing that analyzes data and produces results is where the real value creation occurs. The introduction of compute virtualization makes this problem worse as it creates more traffic on the server both internally between VMs or containers and externally to other servers or storage. Applications such as software-defined storage, SDS, hyper-converged infrastructure, HCI, and big data also increase the amount of east-west traffic between servers, whether virtual or physical, and often remote direct memory access RDMA is used to accelerate data transfers between servers. Through traffic increases and the use of overlay networks such as VLAN, NVGRE, or GENEVE, increasingly popular for public and private clouds, adds further complications to the network by introducing layers of encapsulation. Software-defined networking, SDN, imposes additional packet steering and processing requirements and adds additional burden to the CPU with even more work, such as running the Open vSwitch, OVS. DPUs can handle all this virtualization, SR-IOV, RDMA, overlay network traffic encapsulation, OVS overload, faster, more efficiently, and at lower cost than standard CPUs. Another reason, security isolation. Sometimes you might want to isolate the networking from the CPU for security reasons. The network is the most likely vector for a hacker attack or malware intrusion, and the first place you'd like to detect or stop a hack. It's also the most likely place to implement inline encryption. The DPU, being a NIC, is the first, easiest, best place to inspect network traffic, block attacks, and encrypt transmissions. This has both performance and security benefits, as it eliminates the frequent need to route all incoming and outgoing data back to the CPU and across the PCIe bus. It provides security isolation by running separately from the main CPU. If the main CPU is compromised, then the DPU can still detect or block malicious activity. The DPUs can work to detect or block attacks without immediately involving the CPU. For more information about the security benefits of a DPU, see Foreshadowing the Future of Security Meltdowns. Wow, okay. And the specter of a breach. And if we remember situational awareness, the key point in situational awareness was there's basically no security in these data centers, especially not against the sophisticated efforts of foreign state security agencies, kind of equivalent to the FBI and like the CIA, right? So like the Chinese version of the CIA is going to overcome this, dinky security. So it might be interesting to learn about what they've got so far, but according to that document, things are going to change rapidly in that space. All right, so virtualizing storage and the cloud. A newer use case for DPUs is to virtualize cloud-defined storage, hyperconverged infrastructure, and other cloud resources. Before the virtualization explosion, most servers just ran local storage, which is not always efficient, but it's easy to consume. Every OS, application, and hypervisor knows how to use local storage. Then came the rise of network storage, SAN, NAS, and more recently, NVMe over Fabrics, NVMe-OF. It doesn't stand for OnlyFans. However, not every application is natively SAN aware. Some operating systems and hypervisors, like Windows and VMware, don't speak NVMe-OF yet. Something DPUs can do is virtualize networked storage, which is more efficient and easier to manage, to look like local storage, which is easier for applications to consume. A DPU could even virtualize GPUs or other neural network processors so that any server can access as many GPUs as it needs whenever it needs them over the network. A similar advantage applies to software-defined storage and hyperconverged infrastructure. Both use a management layer, often running as a VM or as a part of the hypervisor itself, to virtualize and abstract the local storage and the network to make it available to other servers or clients across the cluster. This is wonderful for rapid deployments on commodity servers and is good at sharing storage resources. However, the layer of management and virtualization soaks up many CPU cycles that should be running the applications. As with standard servers, the faster the networking runs and the faster the storage devices are, the more CPU must be devoted to virtualizing these resources. Here again is where the intelligent DPU creates efficiencies. First, it offloads and helps virtualize the networking. They accelerate the private and public cloud, which is why they are sometimes called cloud NICs. They can offload both the networking and much or all the storage virtualization. DPUs can also offload a wide variety of functions for SDS and HCI, such as compression, encryption, deduplication, RAID, reporting, and so on. This is all in the name of sending more expensive, and we need some more time on the clock here, more expensive CPU cores back to what they do best, running applications. So figure 1, DPU is a programmable specialized electronic circuit board with hardware acceleration of data processing for data-centric computing. And I need a quick break, so I'll pause the clock. We can even reset it, doesn't matter. And I'll be right back. All right, welcome back. So more time on the clock here. And let's try to keep this going here. So must have hardware acceleration. Having covered the major DPU use cases, You know when you need them and where they can provide the greatest benefit. They must be able to accelerate and offload network traffic. They might as well need to virtualize storage resources, share GPUs over the network, support RDMA, remote direct memory access, and perform encryption. Now, what are the top DPU requirements? First, all DPUs must have hardware acceleration. Hardware acceleration offers the best performance and efficiency, which also means more offloading with less spending. The ability to have dedicated hardware for certain functions is key to the justification for a DPU. Must be programmable. For the best performance, most of the acceleration functions must run on hardware. For the greatest flexibility, the control and programming of these functions must run in software. There are many functions that could be programmed on a DPU, and a few of which are outlined in the feature table of my previous post. Usually the specific offload methods, encryption algorithms, and transport mechanisms don't change much. But the routing rules, flow tables, encryption keys, and network addresses change all the time. The former functions are the data plane, and the latter functions are the control plane. The data plane rules and algorithms can be coded into silicon after they are standardized and established. The control plane rules and programming change too quickly to be hard-coded in silicon, but can run on FPGA, modified occasionally but with difficulty, or in a C programmable Linux environment, modified easily and often. I think this means field programmable something. Field programmable gate array. All right, so now we have a table. So we have the DPU function, the use case, run in hardware, data plane, and then run in hardware in the control plane. So packet inspection is a function of the DPU. It's for intrusion detection and firewall. In the data plane, it does packet filtering, header inspection, and rewriting. And then in the control plane, it does rules, reporting, packet content inspection. The next entry is flow table processing. The use case is virtual routers, OVS, and firewall. And OVS, I forget what that stands for. So it's like a it's like a virtual multi-layer switch. So it does virtual routing, virtual switching, and firewalls. And then in the data plane, it does packet switching. In the control plane, it defines switching rules and flow tables. The next DPU function is encryption. Use case is for security and privacy. In the data plane, it does transport and networking. In the control plane, it does addressing and connections. The next DPU function is DPDK/OVS. Use case is NVF, which network function virtualization. And in the data plane, it does packet switching. In the control planing, it does rules and reporting. Then the next is VXLAN overlays. The use case is for public/private cloud. In the data plane, it does encryption/decryption, and then VTFP, so virtual is that correct, or is that an error? Let's see. Yeah.
Yes, VDFP seems to be a typo in this context.
Right.
It is likely that they intended to reference VDFP, which stands for Virtual DAP, a technology used for monitoring network traffic. Another possibility is VTEP, which
I
stands for
think this
VXLAN
is
Tunnel
what they
Endpoint, a key
mean.
component in VXLAN overlays. The correct term depends on the specific functionality being discussed, but VDFP does not appear to be a recognized term in this context.
Yeah, I think this is meant to be VTEP. I really think this is an error. So this is VXLAN tunnel endpoint. Yeah, so making a tunnel makes more sense in this context than whatever this is. So I think this is a typo. It's meant to say VTEP. And then in the control plane, it's for overlay definitions. So the DPU function, the next one is NVMe-OF. And the use case is flash storage. The data plane is NFMe-OF protocol for remote direct memory access. And then in the control plane, it's connection setup, RAID, and provisioning. And I forget exactly what this stands for, so let's go back and check. So over fabrics is what it stands for. All right, so this table was the DPU function guidelines. So how much programming has to live on the DPU? You have a choice of how much of a DPU's programming is done on the adapter. That is, the adapter's handling of packets must be hardware accelerated and programmable, but the control of that programming can live on the adapter or elsewhere. If it's the former, we say the adapter has a programmable data plane for executing the packet processing rules and control plane for setting up and managing the rules. In the later case, the adapter only does the data plane while the control plane lives somewhere else, like the CPU. For example, with Open vSwitch, the packet switching can be done in software or hardware, and the control plane can run on the CPU or on the DPU. With a regular foundational or dumb NIC, all switching and control is done by software on the CPU. With a smart NIC, the switching is run on the adapter's ASIC, but the control is still on the CPU. With a true DPU, the switching is done by ASIC type hardware on the adapter, while the control plane also runs on the adapter in easily programmable ARM cores. So here we go. We have figure 2, which is ConnectX-5 Smart NIC offloads OVS switching to NIC hardware. So we've got left and the right. On the left, we've got 2 VMs connecting with ConnectX-5 vSwitch. Bidirectional arrow. This is the data path. So these VMs are SR-IOV, VF, both of them are. And then the ConnectX connects it up to the hypervisor through, and then the hypervisor does flow overload in one direction towards the eSwitch. Bidirectionally, there's a P and an F. I don't know what that stands for. And the hypervisor is OVS. And then on the right, we have, so we can see how that offloads what we had on the right. On the right, we had hardware forwarded packets going through the eSwitch, subsequent packets handled by the software. The eSwitch is the hardware, and then the first packet goes up to the user kernel to OVS-VS switch D. So by using Smart Connect, snitching or switching, not snitching. So switching can be done directly to the hypervisor. So I think you don't have to have the first packet go all the way up here to the user kernel. I think that's what that means. Anyway, moving on. We're already double over time. What is best, DPU or SmartNIC? To achieve application efficiency in the data center, both transport offload and a programmable data path with hardware offload for virtual switching are vital functions. According to the definition, these functions are part of a SmartNIC and are table stakes on the path to a DPU. However, just transport and programmable virtual switching offload by themselves don't raise a smart NIC to the level of a DPU. Customers often tell us they must have a DPU because they need programmable virtual switching hardware acceleration. This is mainly because another vendor competitor with an expensive, barely programmable offering has told them a DPU is the only way to achieve this. In this case, we are happy to deliver the same functionality with the ConnectX family of smart NICs, which are very smart NICs after all. But by my reckoning, there are a few more things required to take a NIC to the exalted level of a DPU, such as running the control plane on the NIC and offering C programmability with a Linux environment. In those cases, we're proud to offer the Bluefield DPU, which includes all the smarter NIC features of ConnectX adapters, plus from 4 to 16 64-bit ARM cores, all running Linux, of course, and easily programmable. As you plan your next infrastructure build-out or refresh, remember these key points. DPUs are increasingly useful for offloading networking functions and virtualizing resources like storage, networking, and GPUs. Smart NICs or smarter NICs accelerate data plane tasks in hardware, but run the control plane in software. The control plane software and other management software can run on the regular CPU or on a DPU. Nvidia offers best-in-class intelligent smart NICs, ConnectX, field programmable gate array NICs, Innova, and fully programmable data plan slash. There's another typos. I'm a typo guy. I'm sorry. I'm a typo guy. Typos bother me. So it should say data plane. They're missing an E. / control plane DPUs. Bluefield programmable DPU. All right, and written by Mr. Typo himself, Kevin Deerling. So that's it for that one. So moving on to the next one. So the next one is transforming the data center with DPUs. Let's get through this one. Take a little bit of an extended break for me. For anyone watching, it'll be instant. And then finish this up. All right, so Nvidia Bluefield networking platform. Advanced infrastructure computing platform for powering the world's data centers. Transform the data center with Nvidia Bluefield. The Nvidia Bluefield networking platform ignites unprecedented innovation for modern data centers and supercomputing clusters. With its robust compute power and integrated software-defined hardware accelerators for networking, storage, and security, Bluefield creates a secure and accelerated infrastructure for any workload in any environment, ushering in a new era of accelerated computing and AI. So we have Bluefield in the news. Las Vegas Sphere, which is definitely in the news, delivers dazzling displays powered by Nvidia Bluefield DPUs. Sphere, a next-generation entertainment medium in Las Vegas, offers stunning visuals on the world's largest LED screen with Nvidia RTX GPUs and robust connectivity powered by Nvidia Bluefield DPUs and Nvidia RiverMax software. Nvidia GB200 NVL72 platforms arrive equipped with Nvidia Bluefield-3 DPUs. Flagship rack-scale platforms powered by the Grace Blackwell accelerator and Nvidia Bluefield-3 networking innovations enable breakthroughs in data processing for the most compute-intensive workloads. And the final piece of news regarding Bluefield is new NVIDIA DGX SuperPod architecture built with DGX GB200 systems and NVIDIA Bluefield-3 DPUs. The DGX GB200 systems at the heart of the Blackwell-powered DGX SuperPod architecture feature NVIDIA Bluefield-3 DPUs for providing next-generation networking and high-performance storage access. Okay, so there's a portfolio of Bluefield networking platforms. The first in the portfolio, and there's only 3, thankfully, is the NVIDIA Bluefield-3 DPU. The Nvidia Bluefield-3 DPU is a 400 gigabit per second infrastructure compute platform with line rate processing of software-defined networking, storage, and cybersecurity. Bluefield-3 combines powerful computing, high-speed networking, and extensive programmability to deliver software-defined, hardware-accelerated solutions for the most demanding workloads. From accelerated AI to hybrid cloud, high-performance computing to 5G wireless networks, Bluefield-3 redefines the art of the possible. All right, so the next Bluefield networking platform is the Nvidia Bluefield-3 SuperNIC. So remember reading about that recently. The Bluefield-3 SuperNIC is an advanced network accelerator purpose-built for supercharging hyperscale AI workloads. Designed for network-intensive, massively parallel computing, the Bluefield-3 SuperNIC provides up to 400 gigabit per second of remote direct memory access, RDMA, over converged Ethernet, ROCE, network connectivity between GPU servers, optimizing peak AI workload efficiency. Creating a new era of AI cloud computing, the Bluefield-3 SuperNIC enables secure multi-tenant data center environments with deterministic and isolated performance between jobs and tenants. So the next is Nvidia Bluefield-2 DPU. The Nvidia Bluefield-2 DPU provides innovative acceleration, security, and efficiency in every host. Bluefield-2 combines the power of the Nvidia ConnectX-6DX with programmable ARM cores and hardware overloads for software-defined networking, storage, security, and management workloads. Bluefield-2 delivers superior performance, security, and reduced total cost of ownership for cloud computing platforms, enabling organizations to efficiently build and operate virtualized, containerized, and bare metal infrastructures at massive scales. The next is Nvidia DOCA, unlocking data center innovation by enabling the rapid creation of applications and services to the Bluefield networking platform with the Nvidia DOCA software development kit. Networking for the era of AI. Nvidia Ethernet SuperNICs emerge as a new class of network accelerators purpose-built to... Oh, and need more time on the clock. Hopefully not much more. Purpose-built to supercharge network-intensive, massively distributed AI computing workloads. So now we've got resources. Discover more ways to transform your data center. So one of the ways is cloud networking. So securely, you can securely deploy and operate NVIDIA AI clouds powered by NVIDIA Bluefield-3 DPUs for NVIDIA AI systems. Another way is network infrastructure. Do you need to update your data network center? Normally, data center networks are your data center network. Normally, data center networks are updated when new applications or servers are installed in the infrastructure. But independent of new server and application infrastructure forcing an update, there are other areas to consider. Learn the 3 questions to ask when assessing if you need to update your network. So we're not going to learn that. Now we have ecosystem. So secure next generation apps over VMware Cloud Foundation with the Bluefield-2 DPU. The integration of the NVIDIA Bluefield-2 DPU within the next generation VMware Cloud Foundation creates a powerful enterprise cloud platform with best-in-class security, operational efficiency, and ROI. It's a secure architecture for the modern enterprise private cloud, leveraging VMware and accelerated by both DPU and GPU. The accelerators provide security, lower TCO, which stands for total cost of ownership, higher performance, and new functionality that wasn't possible before. So now this is power efficiency, which would skip me down to this is ecosystem, which skip me. So I'm not sure what I'm meant to read on this page. It was only meant to be. Now this was meant to be. Yeah, this is only meant to be 5 minutes. So we're already at 7 minutes. So I think I'm gonna kind of skip around. Well, you know what? Let's just keep going. I think I am meant to read everything. Okay, so I think we read about resources already. So now developer. Get a software perspective on DPU-based hardware acceleration. Data processing units, DPUs, provide greater data center efficiency, but low-level programming requirements have hindered broad adoption. Nvidia's DOCA software framework, which abstracts the programming of data field DPUs, removes this obstacle. Hear from Linely Group analyst Bob Wheeler how customers will be able to perform future converged DPU and GPU hardware using the combination of DOCA and CUDA. All right, next is power efficiency, which skips me down. Oh, you know what? It's because I'm using a different set of tabs. Okay, so here's the final tab of this set of tabs. So deploy NVIDIA cloud native architecture for bare metal secure supercomputing. High performance computing, HPC, and AI have driven supercomputers into wide commercial use. They've been the primary data processing engines for research, scientific discoveries, and even product development. When designing a supercomputer architecture, the goal is twofold: to mitigate factors that impact performance and to accelerate application performance whenever possible. All right, so that takes me to, so we've got some featured articles here, which this I'll definitely skip. And now we've got power efficiency with DPUs. So NVIDIA Bluefield DPUs drive data center efficiency. So we could read this to learn about how DPUs reduce power consumption in testing with key NVIDIA partners. Then we've got DPU power efficiency research. NVIDIA DPUs can reduce power consumption by 30%, saving $56 million for large data centers. Find all of NVIDIA's test results on the power consumption of various DPUs. And then the final way that DPUs are more power efficient is by creating a power efficient. Okay. Well, that's not a way that it's more efficient. You can use them to Bluefield DPU power savings research and get answers. So if you want more information, you can watch a webinar there. But the key benefits of Bluefield are peak AI workload efficiency. Bluefield accelerates AI performance with robust ROCE networking, NVIDIA Direct, RDMA, and ROCE, data direct placement, and programmable congestion control, creating an exceptionally fast and efficient network infrastructure for AI. Security from the perimeter to the cloud. Bluefield enables a zero-trust security everywhere architecture where security goes beyond the data center perimeter to the edge of every server. Data storage for expanding workloads with NVMe over fabrics. GPU direct storage, encryption, elastic storage, data integrity, decompression, and deduplication. Bluefield provides high-performance storage access with latencies for remote storage that rival direct attached storage. And then we have high-performance cloud networking. Bluefield is a powerful cloud infrastructure processor delivering up to 400 gigabits per second of Ethernet and InfiniBand connectivity for both traditional applications and modern workloads, while freeing host GPU cores to run applications instead of infrastructure tasks. Okay, so now we've got featured Bluefield technology environments, and I think that'll be it. Afterwards, these are just examples of companies that use the solutions. So, yeah, notably absent is well, I mean, to be fair, like Cisco is a competitor. It's another networking company. Oh, and there it is. Look, so Cisco and Juniper are listed here. They use this for security purposes. So there we go. And Cloudflare, Palo Alto, they're all right there. But this is kind of a snapshot into which are part of this ecosystem. So I think this is important to take a look at. Yeah, so when you're going for a certification, you might want to consider the security track because it's part of this NVIDIA's ecosystem, and NVIDIA is definitely going to be a major player in the multi-trillion-dollar AI industry that will grow in the next 10 years. Okay, so the first featured Bluefield technology environment is Scale Enterprise RAG with NVIDIA Bluefield networking. In the era of generative AI, Retrieval Augmented Generation, RAG, empowers enterprises to capitalize on their data. Learn how Bluefield enables businesses to deploy scalable and efficient RAG, Retrieval Augmented Generation, workflows. The next one is Bluefield Enhanced Servers, Supercharged Generative AI for Enterprises. The world's leading system manufacturers are building AI-ready servers featuring NVIDIA L4 OS GPUs, NVIDIA Bluefield-3 DPUs, NVIDIA SuperNICs, and NVIDIA AI Enterprise software to help enterprises customize and deploy generative AI applications. The next is Transform HPC Data Centers with NVIDIA Bluefield. Providing powerful computation, high-speed InfiniBand networking, and highly programmable engines, NVIDIA Bluefield networking platform ignites unprecedented innovation and performance for modern scientific computing applications. Then we have Boost Security with the NVIDIA Morpheus AI framework. NVIDIA Morpheus is an AI application framework that provides cybersecurity developers with a highly optimized AI pipeline and pre-trained AI capabilities that bring a new level of security to data centers. The Morpheus framework provides highly scalable and adaptive data ingest, pre-trained AI models, and policy control functions, enabling cybersecurity developers to detect and remediate security threats. The next Bluefield technology environment that's featured in this article is delivering high-performance software-defined 5G with this one here, NVIDIA AX800. The NVIDIA AX800 Converged Accelerator delivers high-performance 5G. So this is for like radio towers. So RAN makes sense in this case, which stands for radio something something. Radio access network. The NVIDIA AX800 Converged Accelerator delivers high-performance 5G with deep integration of the Bluefield-3 DPU and A800 GPU, allowing cloud service providers to host 5G RAN and AI services on multi-tenant GPU cloud infrastructure. So the next one is Oracle Cloud Infrastructure chooses NVIDIA Bluefield Networking. Oracle Cloud Infrastructure, OCI, is advancing sustainability goals by using Bluefield DPUs to offload data center tasks from CPUs, achieving greater performance, efficiency, and security. All right, so that's it. I'm going to reiterate again the solutions ecosystem that's really tapped in with NVIDIA, which is not going anywhere, and but by that I mean is going to continue to be a major player as this multi-trillion-dollar industry rises. So we can get a sense, if you're going for cloud, it's kind of concerning that. AWS is not listed here, so maybe look at Azure, maybe look at Oracle, but the goal is to hit a moving target, right? So like even though it's the biggest now, you might want to consider getting two, right? You might want to consider getting the biggest now, but also one of these might make sense as the industry continues to grow. And then of course, these are moving targets too. It could be that tomorrow there's some big contract and they drop one of these and get AWS instead. So you never know. It's hard to predict the future, but I think these are it's very relevant that these companies are listed here. All right, so so just 6 minutes left, which for me means half an hour, but but I can get it all done in this one video. I can do 2 hours today. I'm feeling strong. So we're just gonna get it all done here and now in this one video. After a break, so I'll change my Control F. There we go. And then I'll put some time on the clock for 3 minutes, and I'll take a break, and we'll close this out after I get back. So I'm gonna take a break, but it'll be instant. All right, so let's close it out. So 3 minutes on the clock. Nvidia DOCA software framework. Accelerate application deployment for Nvidia Bluefield and ConnectX networking devices. Nvidia DOCA unlocks the potential of the Nvidia Bluefield networking platform by harnessing the power of Bluefield DPUs and Super NICs. DOCA enables the rapid creation of applications and services that offload, accelerate, and isolate data center workloads. It lets developers create software-defined cloud-native DPU and Super NIC accelerated services with zero trust protection, addressing the performance and security demands of modern data centers. DOCA host includes all needed host drivers and tools for your Nvidia Bluefield and DirectX not DirectX. I don't know why I thought of that. ConnectX devices. So here we have a graphic. Graphics doesn't have a label, but we have applications. So the applications everyone in IT should be familiar with. What are the common applications of IT? There's networking, there's security, there's storage, there's high performance computing, there's artificial intelligence, and there's telco / media. And then NVIDIA DOCA, what that does is a number of services. It has orchestration, telemetry, Firefly, OVS, which is like a virtual switch, /DOCA, /P4RT, /HBN. Then it has DPU management. So DOCA libs are crypto, AppShield, HPC, AI, GPU, NetIO, RiverMax, Flow, UROM, COM channel, storage, PCC, DPA, and then DOCA drivers are networking, ASAP, DPDK, XLIO, security, DPDK, SFT, inline crypto, then storage, SBDK snap, VirtIO-FS, XTS crypto, then UCC, UCX, RDMA, and FlexIO. So this is the Nvidia Bluefield DPU, Bluefield Super NIC, and ConnectX. So together, DOCA and Bluefield networking platform enable the development of applications that deliver breakthrough networking security and storage performance. Bluefield isolates the infrastructure service domain from the workload domain to offer significant improvements in application and server performance, security, and efficiency, giving developers all the tools they need to realize optimal, secure, accelerated data centers and AI clouds. DOCA software consists of an SDK and a runtime environment. We need more time on the clock. Thankfully, not that much more, hopefully. The DOCA runtime, included by default with the Bluefield networking system, has tools for provisioning, deploying, and orchestrating containerized services on hundreds or thousands of DPUs and Super NICs across the data center. The DOCA SDK provides industry-standard open APIs and software frameworks. The SDK supports a range of operating systems and distributions and includes drivers, libraries, tools, documentation, and example applications. DOCA-host is the DOCA package for host installation and includes several installation profiles to best fit your data center workflows. DOCA host provides the needed interfaces for NVIDIA networking platforms, including both Bluefield and ConnectX devices. So we've got more information here. I don't think I have to read this because it's so this is the DOCA software framework. So you know what? I think this probably is part of it. I'm so slow. I'm so slow. It's probably part of it. So platform and host deployments, DOCA on Bluefield networking platform. The Nvidia Bluefield networking platform, powered by the DOCA software framework, is an advanced computing platform for data center infrastructure, delivering accelerated software-defined networking, storage, security, and management services at massive scale. Then we have DOCA on the host. Nvidia Bluefield and Nvidia Connect-X are paired with DOCA to deliver Ethernet and InfiniBand connectivity solutions at speeds up to 800 gigabits per second GB/s. Built on an open foundation, the DOCA-host package includes essential drivers and tools to enhance networking performance and enable advanced functionality. DOCA software is available on every leading operating system as a standalone package without a bundled OS for ARM and x86 architectures. All right, so next we have Unpack the Stack. Bluefield Software Bundle. The Bluefield Software Bundle includes the bootloader, OS kernel, necessary network interface card, NIC, firmware, NVIDIA drivers, sample file system, and toolchain, all certified as part of the NVIDIA NGC catalog. The Bluefield bundle includes Ubuntu 22.04 as a commercial-grade Linux distribution with continuous OS and security upgrades. So here's a graphic here, so we can open that image in a new tab to see it bigger. And we've got NVIDIA Bluefield DPU/SuperNIC, and on top of that, we've got ARM. Bluefield cores, so NVIDIA Bluefield cores that contain the Bluefield operating system. So I think you can. I'm not sure about that. I was about to say I think you can SSH into your DPU, but I'm not sure if that's the case. And then DOCA framework, open APIs and services, and then infrastructure. Applications containers. Let's have a quick chat. So what is an NVIDIA DPU?
An NVIDIA DPU, data processing unit, is a programmable.
Okay, yeah. So it knows what an NVIDIA DPU is. So let's see. Can you SSH into an NVIDIA DPU? Probably no. I'm guessing no. Oh, you can. Okay.
Yes, you can SSH secure shell into an NVIDIA DPU, specifically into the embedded ARM cores that are part of the DPU architecture. NVIDIA's Bluefield DPUs, for example, include a set of ARM CPU cores that run a full Linux operating system.
Yeah.
These cores can be accessed over the network using SSH, allowing administrators to manage, configure, and troubleshoot the DPU directly.
Yeah.
Steps to SSH into an NVIDIA DPU. Network setup. Ensure that the DPU is correctly.
Can you cite your source and show me the link where you learned that this is true? Okay, so right here. And then if we search for SSH. Yeah, SSH into your DPU. See, I was right about that. Like, that's what it means for it to have a full operating system in it. You can SSH into it. You can run games on it if you want, if you install them to it. It's a machine. It's its own computer. All right, so let's look at the next one. It's we got functional isolation. So the business application domain is isolated from the infrastructure services domain. The business application domain has the host OS / the container OS, and then the infrastructure services domain has the host, the DPU, and the DOCA. And I forget what DOCA is. In this context, what does DOCA mean?
In this context, DOCA stands for Data Center Operating System Architecture. It is NCA-AIDC's software framework designed to simplify the development of applications that leverage the full capabilities of NVIDIA DPUs, data processing units, like the Bluefield series.
All right, so that makes sense. So SDK key components, ROCA RDMA, Remote Direct Memory Access, Acceleration SDK, Unified Communications and Collaboration UCC, and Unified Communication X UCX, RDMA Verbs, GPT Direct. Then we have Network Acceleration SDK, Nvidia Accelerated Switching and Packet Processing ASAP2, Software Defined Networking SDN, Emulated VirtIO P4, 5T for 5G technology, Firefly Time Synchronization. Then we have Security Acceleration SDK, Inline Cryptography, App Shield Runtime Security, Storage Acceleration SDK, Storage Emulation and Virtualization, Crypto and Compression, Data Path Acceleration, DPA SDK, Accelerate Workloads requiring high performance access to NIC engines, then Management SDK, Deployment Provisioning Service Orchestration. Then we have Industry Standard APIs, DPDK, SPDK, P4, Linux Netlink, and then User Space and Kernel. And finally, we have forward and backward compatibility. DOCA, which remember stands for Data Center Operating System Architecture, provides multi-generational support to ensure that applications developed today will consistently run with added performance benefits on all future generations of Bluefield. Then offload, accelerate, isolate infrastructure. Network storage and security services are offloaded, accelerated, and isolated on Bluefield, while data is securely delivered to workloads at wire speed. And then open ecosystem. DOCA offers a software application framework to accelerate ecosystem development. So there we go. We have developer resources. And then we have host. So that's it. 3 minutes. I'm more than 3 times over the clock, but not 4 times. So that's, for me, that's a victory. All right, and even more of a victory. One more left to read. So big deal there. Okay, so now we have an entire. I don't know how they think this is going to take 3 minutes. So I guess it should take 3 minutes if. Man. Yeah, I don't know how they think this is going to take 3 minutes, but I'll give it a shot. I actually want a quick break. I'll be right back. All right, I'm back. So big moment. Let's close this thing out. 3 minutes on the clock. So this is the data sheet for the Nvidia Bluefield-2 DPU data center infrastructure on a chip. The Nvidia Bluefield-2 data processing unit DPU is the world's first data center infrastructure on a chip, optimized for traditional enterprises, modern cloud workloads, and high-performance computing. It offers a broad set of accelerated software-defined networking, storage, security, and management services with the ability to offload, accelerate, and isolate data center infrastructure. With its 200 gigabit per second Ethernet or InfiniBand connectivity, the Bluefield-2 DPU enables organizations to transform their IT infrastructures into state-of-the-art data centers that are accelerated, fully programmable, and armed with zero-trust security to prevent data breaches and cyber attacks. Which I'm curious what that means for SSH. You know what? I'm curious enough to, I'm going over time anyway, so I'm curious enough to ask the AI about that. So in this context, when it comes to zero trust security to prevent data breaches and cyber attacks, what does that mean for the SSH access to the DPU? How is that handled so that it's zero trust security?
In the context of NCA-AIDC's Bluefield DPU, zero trust security is an approach that assumes no implicit trust for any entity, whether inside or outside the network. Instead, every access request is thoroughly authenticated, authorized, and continuously validated. This approach is crucial in preventing data breaches and cyber attacks. How zero trust applies to SSH access. Strict authentication. SSH access to the DPU is protected by strong, multi-factor authentication mechanisms.
All right.
This ensures that only authorized users can access the DPU, reducing the risk of unauthorized access. Role-based access control, RBAC, zero trust principles often involve limiting access based on the principle of least privilege. SSH access can be
But that stuff doesn't seem that secure to me, to be honest. How secure is that really, especially in the face of like foreign state acting intelligence agencies?
Your concern about the security of SSH access, especially in the context of defending against sophisticated threats like those from foreign state-sponsored intelligence agencies, is valid. While the measures described for zero trust security in NVIDIA DPUs do provide a robust level of protection, it's important to understand both the strengths and potential weaknesses of such a system in the face of highly advanced adversaries. Strengths of the security approach: strong encryption. SSH sessions are typically encrypted using strong algorithms, like AES, making it extremely...
Yeah, so this is what I mean, right? Like there's 0-day vulnerabilities, no matter what you do, like, there might be something not thought of that the attackers can use. And I'm way over time now, but I'm kind of purposely going over time because I'm learning more about this last part. Social engineering, like, just they'll get assigned an account, right? So it's and this is the whole point of what was being talked about in situational awareness. Security is going to be a major issue. It already is when it comes to AI. By combining the industry-leading Nvidia Connect X-6 DX network adapter with an array of ARM cores and infrastructure-specific offloads, Bluefield-2 offers purpose-built hardware acceleration engines with full software programmability sitting at the edge of every server. Bluefield-2 empowers agile, secured, and high-performance cloud and artificial intelligence AI workloads, all while reducing the total cost of ownership and increasing data center efficiency. The Nvidia DOCA software framework enables developers to rapidly create applications and services for the Bluefield-2 DPU. Nvidia DOCA makes it easy to leverage DPU hardware accelerators, providing breakthrough data center performance, efficiency, and security. Software-defined hardware accelerated applications. So we've got networking, vSwitch, vRouter, NAT, load balancer, NFV. We've got storage, NVMe over Fabrics, NVMe-OF, elastic storage virtualization, hyper-converged architecture, HCI, encryption, data integrity, compression, data deduplication, security, next-generation firewall, IDS/IPS, root of trust, micro-segmentation, DDoS prevention. So the key features of the data center infrastructure on a chip, NVIDIA Bluefield-2 DPU, is security, storage, networking, management, and portfolio. For security, it's hardened isolation layer, hardware root of trust, IPsec/TLS, and AES-XTS encryption acceleration tracking for stateful firewall, and IDS/IPS, regular expression, regex matching accelerator. Then it's storage, NVIDIA GPU Direct Storage, elastic block storage enabled by Bluefield Snap Storage Virtualization, compression and decompression acceleration, NVMe/OF acceleration, VirtIO/BLK acceleration. Then it's networking, ROCE, zero trust ROCE, GPU Direct, SDN acceleration powered by NVIDIA ASAP squared, acceleration, switching, and packet processing. And I guess I don't know what this symbol is. It's a trademark or something. Overlay network offloads, including VXLAN. Then we've got management, authenticated product lifecycle management, telemetry agents. Then we've got portfolio, dual ports of up to 100 gigabit per second, or a single port of 200 gigabit per second Ethernet or InfiniBand. Then we've got 16 gigabit/32 gigabit of onboard DDR4 memory. Then we've got card form factors, HHHL and FHHL, and then 1 gigabit Ethernet out of band management port. All right, now we've got a lot of features here. I feel like this would definitely go over the time, but it's the last one, so I'm okay with that. So we see the DPU-2, the Bluefield-2 DPU comes in 3 flavors. It comes in 2 by 25 gigabit per second HHHL form factor. It also comes in the 2 by even faster speed 100 gigabit per second FHHL form factor, and I don't know what the F or the H, I don't know the difference between those two. And then the next is DPU Bluefield-2 DPU 1 by 200 gigabit per second HHHL form factor. So let's see what the difference is between the two. So what's the difference between HHHL and FHHL? Like, what do they stand for, and what's the difference between the two?
The acronyms HHHL and FHHL refer to different types of form factors for PCIe, Peripheral Component Interconnect Express cards, commonly used in various hardware components like DPUs, GPS, and network interface cards.
Oh, I see.
HHHL, half height, half length.
So that's really easy, right? So we can see, oh, wait, what? Oh, so this must be kind of a misleading graphic. Okay, so would you say then that the graphics in the screenshot I posted earlier are kind of misleading? The first image, since it's an HHL, half height, half length, that should be half the size as the next one, which is full height, half length. So it seems like a pretty misleading graphic, right? And you can kind of see it because the PCI slot on the first graphic is a lot shorter than the other one. It's a mini slot, and the other one has a full slot. So it kind of makes sense in that regard. But is that the case, or are the graphics accurate?
You're correct in observing that the graphics in the screenshot could be potentially misleading. Here's why. 1. Form factor differences. HHHL, half height, half length. As you noted, this form factor is indeed smaller in both height and length compared to FHHL, full height, half length.
Yeah, so there's a typo in this. I think this is a pretty serious typo. You can see the difference here. You can see that this half height, half length. Wait, you know what? Maybe this HHL doesn't stand for that. Maybe the AI is hallucinating, because these should be the same size, right? If that's what that means. So yeah, I don't know what's going on with that. Anyway, the features are network and host interfaces. Network interfaces, Ethernet, dual ports of 10, 25, 50, 100 gigabits per second, or a single port of 200 gigabits per second. InfiniBand, so it can use Ethernet or InfiniBand. That's a big deal in the AI data center. It has dual ports of EDR/HDR 100, or a single port of HDR. Then we have PCI Express interface, 8 or 16 lanes of PCIe Gen 4.0, PCIe switch bifurcation with 8 downstream ports. Then we have ARM/GDR subsystem. We have ARM cores, up to 8 ARM v8 A72 cores, 64-bit pipeline. Then we have 1 megabyte level 2 cache per 2 cores, 6 megabyte level 3 cache with plurality of eviction policies. Then we have DDR4 DIMM support, single DDR4 DRAM controller, 16 gigabyte/32 gigabyte of onboard DDR4, and then ECC error protection support. Then we have hardware accelerations, security, secure boot with hardware root of trust, secure firmware update, Cerberus compliant, Cerberus compliant, regular expression, regex acceleration, IPsec/TLS data in motion encryption, AES/GCM 128/256 bit key. We have AES/XTS 256/512 bit data at rest encryption. Then we have SHA 256 bit hardware acceleration, hardware public key accelerator, RSA, Diffie-Hellman, DSA, ECC, EC/DSA, EC/DH. Then we have true random number generator, TRNG. We have storage, Bluefield Snap/NVMe, and VirtIO-BLK. We have NVMe /OF acceleration. We have compression and decompression acceleration. We have data hashing and deduplication for storage. Then networking, ROCE, zero touch ROCE, and I'm not sure what ROCE is. Let's figure out what that is. RDMA over converged Ethernet. So this is remote direct memory access over converged Ethernet. So you can directly access the memory remotely over an Ethernet connection. Then we have stateless offloads for TCP-UDP or /IP. Then we have LSO/LRO/checksum/RSS/TSS/HDS. Then we have VLAN insertion /stripping, SR-IOV, VertIO-NET, multi-function per port, VMware NetQ support, virtualization hierarchies, and then 1,000 ingress and egress QoS levels. For boot options, we have secure boot, which is RSA authenticated. We have a remote boot over Ethernet. We have remote boot over ISCSI, SCSI. We have PXE and UEFI. For management, we have 1 gigabit Ethernet out-of-band management port, NC-SI, MCTP over SM bus, and MCT over PCE. PLDM for monitor and control, DSP 0248, PLDM for firmware update, DSP 026, L2C interface for device control and configuration, SPI interface to flash, eMMC memory controller, and then UART, and then USB. And that's it for all of the you know what? These are well, right. So these are additional materials. The main thing they want is this introduction to AI in the data center. I did that on my own because they were very clear that they didn't want the especially the answers to be shown, which I hope I'm not showing now. No, I'm not showing now. The next step before I take the exam is to take the final exam. So it would be it would be in module 1. There's going to be an exam for each module. And you know what? It might make sense to take this whole course again before the exam, just as review off camera. But now the thing I need to do is schedule the exam and pay the fee and then take it. So I think I'd like to take it next weekend. Next weekend. And then what I'll do in the meantime is this course again. I'll take that final assessment, and then hopefully things will go well. So I'm scared. All right. So I don't want to rack up another fail on this channel. It'd be nice to get successes rather than failures. So yeah, let's take the exam. So we're going to go here, get certified by here. We're going to so we can get other credentials that are not certification. I don't know what that means. Oh, but these are certifications. So I think I take them on Pearson VUE. I don't know. Oh, that was it right there. So register for exam. Let's do it. And now this is register for exam for a different exam. So we got to click register exam for this one. All right, and then the clock can be shut down. All right, so registration is currently closed. Boo. So I think what's going on is this exam. I wish I would have clicked that before I did all the studying for it. My God, what a disaster. So I think the reason, yeah. So the reason this exam isn't listed in this tab is because the registration for it is closed, but it wasn't taken off the site. So this is not a real exam you can take. And I just spent a number of hours, probably 20 hours or so, studying for an exam I wasn't able to take. So welcome to the world of certifications. Yes, it is this bad. And yeah, so well, you know what? I feel like I'm so if we look at the difference between the materials for this one and this one here, we can see there's only one small difference. So if I take all the text in here, so and you can only open one at a time, but so we have to take the AI infrastructure and operations fundamentals versus so a 7-hour course. Oh, and they want you to pay for the course. It's not just on Coursera. Oh my God. It's $49. Okay. Well, this changes things. So yeah, it looks like they changed their program so that this certification is no longer available, and they indicated that by taking it out of the certification tab, but they didn't take it away from other parts of their website. So I wasn't sure what that meant, and I just continued reading about it anyways, which was obviously a mistake. Man, was that a mistake? Well, I'm feeling kind of dumb. Well, good thing I can't take the exam because I feel even dumber when I fail it. So, yeah, okay, well, wow, okay. Yep, welcome to the world of certifications. I'll just say that. It's confusing. It was not listed what this was. They didn't delete it from their site, even though you can't register it for it. Yeah, this site was not properly updated, and as such, I was misled to believing that I'd have the option to take this. Now, that could have been remedied if I had just clicked register for exam right away, but as I was not ready to register for the exam until I finished the training, I did not click it until after I finished the training and lost a lot of time. So I'm gonna ask for yeah, I'm gonna ask for so how can we help? Okay, so I'm gonna say the exam wasn't properly listed as legacy on the site. As such, I didn't click the registration button to realize that I couldn't register until I invested how many hours? A lot. Oh, I don't need to go to YouTube to my email to figure that out. I need to go to YouTube, and I need to look at the playlist. Okay, and now it doesn't say how many hours the playlist is, at least not here. But I think yeah, I think I can get that. So from ChatGPT. So we're gonna say based on the timestamps. Yep. So here we have all. So we've got 11 parts, which should correspond with. Yep, we've got 11 parts here. So then now it's doing the calculation.
The playlist contains approximately 5 hours, 51 minutes, and 15 seconds.
Oh, you know what? That's not that long. I'm not that furious. So let's file a complaint regardless though, because that's fun. All right. So the NDA/NCA wasn't properly listed as legacy with registration closed on the site, nor was it removed. Was it removed? As such, I didn't click the registration button to realize that I couldn't register until after I invested multiple hours into studying for it. Can this please correct this? And they don't give you any time, of course, and then they force you to sign up for the thing. Man. Oh, okay. Well, this is a better place for the support. Customer support. Okay. Well, they really don't have any support for their. Yep. So welcome to the world of certs. This is the world of certifications. Yeah. So that's what's nice about Cisco is like, Cisco, you actually have like a real like certification department that like, you can file like case numbers and you can get actual like assistance from actual people, and like it's not super clear. In fact, it's very unclear. But it's clearer than that. Like that is pretty bad. Like I don't think Cisco will be so ambiguous that you can put in the time to study for something that doesn't exist, like that. So, you know what? I think that's the end of this series. I think I'm man. See, the thing is, like, I'm close to the other one. So I feel like what I might want to do is just do all the study I did for here and try to apply that to the other certification. So if we click on training, and then we click on certification, so I might apply for this one actually. I might be eligible for this one. So like, even though it says that now the you have to pay them for the training, I'm hoping it's similar enough to this Coursera course that I will be prepared for it. So I think I am gonna throw money into this, and go ahead and just go for this one instead, because I already read everything through for that. Now there probably are some differences, but I can detect what the differences are. And then go for there. So let me do that right now. So I'm going to open Notepad++. Or I just need a diff tool. So I can just use that in the bash, but we'll use a website for that. Okay, so we need the original text and then the change text. So let's get the original text. So the original text, we're going to have a list of the ones in here, and then let's get the name of the. Well, let's do that over. So we're gonna first take the name of the code for the certification, okay, and then we're gonna put the topics in it, which I think there's one difference. All right, and then what we're going to do is for each of these, list all of the reading and then see how that differs for the other one. If it's just a few things that are different, then I'll complete the additional materials for the other one, and I will take that test. And I won't pay the $45 for the training for the other one. Maybe if I fail, I might consider it. But I just want to basically see if the Coursera course was enough. So I'll redo the Coursera course. I'll take the final exam on the Coursera course, and then I'll sit for the exam and see how I do. And that'll be a lesson that'll be kind of a solid for anyone following this channel. You can see if this strategy works or not. Although I kind of have a feeling you already know the answer. It won't work. Oh, and I didn't do the topics covered, so I have to keep the spacing consistent, otherwise it'll have some false positives. Yeah, I really wish I had clicked that register button first. Let that be a lesson to anyone. Now, I only burned up about 6 or so extra hours, less than 10 extra hours. But, you know, I've got other goals, so like that time is pretty valuable. All right, so let's see what the difference is now. So we're going to find the difference and lose all my work. Okay, so the difference is the one I studied for, everything's the same, right? So like, you know, not the worst thing in the world. The only difference is where I learned about data center considerations for adopting Nvidia solutions, I'll now have to learn about infrastructure and operation considerations for adopting Nvidia solutions. And then looks like they have kind of a spelling issue there. Everything is exactly the same, except there's another kind of spelling issue there, but it looks like it's the same link. So yeah, look at that. I studied for the exact same thing, even though there is something that was said to be different. None of the additional materials are different. So I feel pretty good with this. So yeah, I'm just going to do the Coursera course again. And look, the name of the Coursera course is even you know, corresponds to that new exam. So change of plans, but not too bad. All I have to do is go back through this module 1. Take the final assessment for that, and then sit for the exam. So the final thing to do is to go to this certification, and now we can go to the certification tab, and we can go to this one, which is exactly the same thing. Honestly, it's exactly the same thing. All the study I did for that other certification, as we saw in this diff checker, was the same that I would need to do for this certification. So hey, good news by the skin of my teeth. So now we can register for this exam. Okay. Okay. Yep, looks good to me. All right, and then off camera, I can give my credit card information, check my email, and schedule it for next weekend. Sorry about that. And then in the meantime, I'll just do this Coursera module 1 again. I hope that's enough. I really hope that's enough. I'm not sure if that's enough. Oh, so it's not enough. I have to take all 4 of them. Yeah, this course is part of preparation material for this. I have to take all 4 of them. All right. Well, I'm a little afraid I don't have enough time. So So yeah, okay. Well, I have to take all 4 of these. I'll worry about the registration more when I'm on module 4. I've still got a bit of work to do, which is kind of good. I think like 5-6 hours, less than 10 hours, isn't enough to really do something like pass an exam. I need to put about 20 hours into it minimum. So I'm kind of glad that there's more to go, because I was really concerned that I'd fail it. And now that I know I've got about 20 hours of work, I actually feel better, because I feel like it's more likely that I'll pass. So this is what I'm going to do just in my own time. I'm going to do this Coursera course. I'm going to do all 4 modules of the course, and then I'll take the exam, and I'll let everyone know the results. So yeah, if you wanted to do this, don't worry if you're in the same situation. They're the same exams. So if you studied for one, you studied for the other. Just be aware that you have to take all 4 of the modules in the Coursera course. And then I actually got scored a solid by studying for that incorrect exam, because I got notified of this Coursera course, which is absolutely free. The other one does not tell you about this, and charges you $45 for the material specific to that. But I'm hoping there's enough overlap here that I'll be able to pass that with this. So with that, that's the end of this video. It's not the end of the series though, because I've got a report on whether or not I passed. So stay tuned for that. It might be a few weeks though.